In this video, we will be seeing different types of ordinary differential equations. Okay, the basic classification. So let's go through the first classification. Linear differential equation. What is a linear differential equation? A differential equation is said to be linear if the combined degree of the unknown function y and its derivatives y dash, y double dash in a term in the equation is at most 1. Okay, so let's see this again. A differential equation is said to be linear if the combined degree of the unknown function y or the dependent variable y and its derivatives y dash, y double dash in a term in the differential equation is at most 1. Okay, so now let's see the examples. Let's write this in terms of y and y dash. X y dash plus y double dash is equal to e power x. So if you take this term, what is the degree of y or its derivatives? It is 1. Okay, in this term, it is 1. So you say that this equation is a linear differential equation. So what is the order here? Order is 2. The highest order term is d square y by dx square and the degree is 1. The degree of the highest order derivative. Okay, this is all about linear differential equation. Now, what is a nonlinear differential equation? A differential equation is said to be nonlinear if it is not linear, that is, the combined degree of the unknown function y or the dependent variable y and its derivatives y dash, y double dash in a term in the equation is greater than 1. Okay, so let's see an example. D square y by dx square plus dy by dx whole square plus y equal to x. So let's write this in y dash and y double dash form. Y double dash plus y dash the whole square plus y is equal to x. So if you see here, the degree here is 1. The degree of y or its derivatives in this particular term is 2. Okay, here it's 1. So you have the degree 2 in this particular term in the differential equation. So you call this nonlinear differential equation, right? So what is the order here? Highest order derivative is d square y by dx square. It's of second order and the degree is 1. Power of the highest order derivative. This is a basic classification of linear and non-linear differential equation. It's very important. Okay. Now, let's answer a question based on the classification of linear and non-linear. So we are given with a differential equation. What is that? D square y by dx square plus x square dy by dx plus x cube y is equal to e power x. Okay, let's write this in terms of y dash, y double dash, etc. X square y dash plus x cube y is equal to e power x. So if you see what are the powers of combined y, y dash and all here, 1. Here, 1. In this term, 1. So this happens to be a linear differential equation. Okay, and what is the order here? Order is 2. And what is the degree here? Order is 2. And what is the degree here? Is 1. Okay, so this is a linear differential equation of first degree. Okay, right? You understood how to classify a given differential equation in terms of linear and non-linear differential equation. Okay, so now let's take another example. The type of differential equation 1 minus x times d cube y by dx cube minus under root 1 plus dy by dx the whole square plus 5y is equal to cos x. Okay, so let's write this equation. d cube y by dx cube minus under root 1 plus dy by dx the whole square plus 5y is equal to cos x. Now take this term to the right hand side. You need to remove the square root here. So 1 minus x times d cube y by dx cube plus 5y minus cos x is equal to under root 1 plus dy by dx the whole square. Okay, so you do squaring on both sides. 1 minus x times d cube y by dx cube plus 5y minus cos x the whole square is equal to 1 plus dy by dx the whole square. So if you see here, this is nothing but y dash the whole square. Okay, the degree is 2 here. So even if there is one term which is having a combined degree more than 1, the equation is non-linear. So what is the order here? What is the highest order derivative? Order is 3. Okay, so this is a non-linear. Okay, non-linear. It's a non-linear differential equation of third order. Okay, now let's take another example. The differential equation dy by dx into d square y by dx square equal to 5y. dy by dx into d square y by dx square is equal to 5y. This is nothing but y dash into y double dash is equal to 5y. If you see this term, the combined degree here is 2. So this is a nonlinear differential equation. And what is the order, highest order here? Order is 2. And what is the degree here? Power of the highest order term. Okay, degree is 1. So this is non-linear of order 2 and degree 1. Okay, this is how you have to solve such problems. They are very common in exams like GATE, ESC. It's very important that you know the nature or the classification of differential equations based on the nature of the differential equation. Okay, so let's see another example. We are given with a Blasius equation. Okay, this is d cube f by d eta cube plus f by 2 into d square f by d eta square is equal to 0. So now you write this, instead of y he has given f, that's all. So this is f triple dash plus f by 2 into f double dash equal to 0. So if you see here, the combined degree is 2. Okay, so this is non-linear. And what is the highest order term in this particular differential equation? Order is 3. Degree is 1. Okay, so what's the answer? This is a third order non-linear ordinary differential equation. Okay, so in this way you have to classify, or you have to find the nature of the differential equation, whether it is linear or non-linear. Okay, let's see another question. The non-linear differential equation from the following options is, he is asking non-linear differential equation. So you can write y double dash plus y dash plus 10y equal to 0. The reason why I am writing like this in terms of y dash, y double dash is at times I've seen few of my students getting confused when the equation is given in terms of dy by dx or d square y by dx square, making very silly mistakes. Okay, so if you write an equation in this way, I think you can avoid doing such mistakes. Okay, so here, now let's look at this equation. What is the degree here? 1, 1, 1. Okay, here y double dash plus y dash the whole square plus 10y is equal to 0. What is the degree here? 1. Here 2. Here 1. So this is non-linear. Right, you can check in the same way the other equations also. Y double dash plus y dash plus 10x equal to 0. So degree here is 1, this is 1. Okay, so you can check here also. Y double dash plus y dash plus 10xy is equal to 0. So here you can see this is 1, this is 1, and this is 1. Okay, there is another small mistake, you can say, like misunderstanding. Okay, so few people think if I multiply with x, it becomes nonlinear. No, you must have a proper judgment when you see the differential equation, which is a dependent variable, which is an independent variable. Is the derivative in terms of y or x is something which you need to figure out when a differential equation is given. Then you have to go about writing the equation in terms of y, y dash, y double dash, etc. and then finding out the combined degree of each term in that differential equation. If you see all the terms are having the degree equal to 1, it's linear. If any one term in the differential equation has a combined degree more than 2 or more than 2, right, or greater than 1, then it's nonlinear. Okay, is this clear? I suppose this classification of linear and nonlinear differential equation is clear. So now let's go to another classification of differential equation, which is nothing but homogeneous differential equation. What is a homogeneous differential equation? A differential equation dy by dx equal to f of x comma y is said to be homogeneous if f of x comma y is a homogeneous function of degree 0 in x and y. Okay, here we are taking degree 0 because we are limited to a particular scope. As I've said in the first video, we are taking the scope of the syllabus being the GATE Engineering Mathematics syllabus. So that is the reason we are taking a homogeneous function of degree 0 in x and y. So let's take an example. Dy by dx is equal to 4xy by x square plus y square. So this is your f of x comma y. Okay, how do you check whether a function is homogeneous or not? F of lambda x comma lambda y is equal to lambda power n times f of x comma y, where n represents the degree. Okay, so you take this function here, f of x comma y as 4xy by x square plus y square. Now you substitute f of lambda x comma lambda y. This is nothing but 4 times of lambda x times lambda y divided by lambda x the whole square plus lambda y the whole square. So if you take lambda common from the numerator and denominator, you get lambda power 0 into 4xy by x square plus y square. This is nothing but lambda power 0 into f of x comma y. So this is a function of degree 0 in x comma y. Such differential equations are called homogeneous differential equations of order 1. Okay, they are first order non-homogeneous differential equations. So when can you say that an equation is non-homogeneous? Okay, it's very simple. When this f of x comma y, okay, is a non-homogeneous function. That is, when you have f of x comma y as x plus y minus 1 by x minus y plus 2 here, okay, you cannot check the homogeneous nature because the function here is non-homogeneous in nature. Okay, you say that this is a first order differential equation which is non-homogeneous. Non-homogeneous first order differential equations. Okay, now let's try answering few questions based on this classification. Now let's try to answer a question. Consider two ordinary differential equations P and Q. So he's asking us to find which one is homogeneous, which one is non-homogeneous. Here, simply take this as f of x comma y and check with the condition f of lambda x comma lambda y is equal to lambda power n times f of x comma y. Okay, here n is 0. Okay, so if you see here, when you substitute x with lambda x and y with lambda y, the lambda in the numerator will be lambda power 4, and the lambda when you take common in the denominator will be lambda power 4. So you will be getting lambda power 0 into f of x comma y. So this is homogeneous. I hope you people understood. That is taking f of lambda x comma lambda y, that is lambda x power 4 plus 3 lambda x the whole square into lambda y the whole square plus 2 lambda y the whole power 4 by lambda x the whole cube into lambda y. Okay, so you can take lambda power 4 common from the numerator from all the terms, lambda power 4 common from the denominator, you will get lambda power 0 into f of x comma y. Okay, the same in the same way you can just check the second one also. This also happens to be a homogeneous function. Okay, so both P and Q are homogeneous ordinary differential equation. So the correct answer is option D. P is a homogeneous ODE and Q is also a homogeneous ordinary differential equation. Alright, is this clear? Now let's take another question. The ordinary differential equation d square u by dx square minus 2x square u plus sin x equal to 0. Okay, he is asking us to check whether this is linear or non-linear or homogeneous or non-homogeneous. Okay, how do you do it? First of all, let's write this equation u double dash minus 2x square u plus sin x equal to 0. So you can observe in the differential equation there is a term called sin x. Okay, whenever you see such terms, the equation will be non-homogeneous. Okay, straightforward. Alright, because there is no concept of degree here. Okay, that you can find out and check whether the function is homogeneous or non-homogeneous. So whenever you see terms like sin x cos x, first of all it's non-homogeneous. And second one, you see the degree of the term here. Degree of u is 1 or its derivative. I think the second derivative is 1. Here the degree of u is 1. So this equation is linear. It is a linear non-homogeneous differential equation. Okay, so the given equation is linear and non-homogeneous differential equations. This is how you need to classify differential equations, or you need to understand the nature of the given differential equation, whether it is linear, non-linear, homogeneous, non-homogeneous. Okay, right? Now, let's see the next classification. This is based on the given conditions for a differential equation. What is an initial value problem? An initial value problem, or in simple terms, IVP, is a differential equation along with appropriate number. Okay, you get this number based on the order of the differential equation. Okay, an IVP is a differential equation along with an appropriate number of initial conditions. Okay, initial conditions. Generally, these problems come when you are solving differential equations under time domain. Okay, you are solving with respect to time. So let's take an example. D square y by dt square plus y is equal to cos 2t. So what is the order here? This is a second order. So how many initial conditions that you need? You need two initial conditions. So if the conditions are given like this, it is understood that he has given the value of y at t equal to 0, time t equal to 0, and y dash at t equal to 0. So when you generally in engineering problems, when time t equal to 0, okay, so you say that as the initial condition. So this particular differential equation along with appropriate number of initial conditions, this entire problem comes under initial value problems. Okay, now what are boundary value problems? A boundary value problem, or BVP, for a given differential equation consists of finding a solution of the given differential equation subjected to given set of boundary conditions. Okay, generally whenever you're solving differential equation with respect to space domain, okay, with respect to a coordinate or space domain, you come across boundary value problems. For example, if you take x square d square y by dx square minus 6y equal to 0, okay, this is again a second order. So how many boundary conditions do you need to solve this differential equation? You will need two boundary conditions. Here y of 0 is equal to 1, y dash of 1 is equal to 1. Here the 0 that you are seeing is not the 0 which you see in an initial value problem. Okay, this 0 and 1 are the coordinates or the locations of the boundaries for a given problem. Okay, so this is value of y at a boundary 0. This is value of y dash at a boundary 1. Okay, that's how you have to read a boundary value problem. You can have a combination also. You can have an initial value problem plus a boundary value problem. Right? This is nothing but an initial boundary value problem, IBVP. Okay, where you will be having both initial conditions, initial condition plus boundary condition. That will be given in the problem. Okay, these are quite common in your engineering domain. If you go to little advanced topics, you will be finding these problems. Okay, initial value plus boundary value problems. Okay, is this clear? The basic difference between an initial value problem and a boundary value problem. I hope you understood the basic classification or basic types of differential equations. That is, a linear and a non-linear differential equation, homogeneous and non-homogeneous differential equation, initial value and boundary value problem in a differential equation. These are very important for you to know the nature of the differential equation. Knowing the nature of the differential equation is fundamentally the first step which a student has to do when he sees a differential equation. Alright, is this clear? I'll be back with another concept in my next video. Thank you.